Okay, so moving on to our next presenter, it's my great privilege to welcome Professor Kate Larson from the University of Waterloo, who will be talking about cooperative AI. Welcome, Kate. The floor is yours.
Okay, thank you. So hopefully everyone can see my slides, and then I'm going to start. Yes, now I'm going to start my slideshow. So thank you very much for this invitation to talk. I'm going to be talking about today is cooperative AI, which is a sort of a future research agenda that both myself and some colleagues from a variety of institutions have been promoting. So I greatly welcome the opportunity to talk about it. So first, what I'm going to be talking about today is cooperation and cooperative problems. And so I need to define my terms. So when I talk about cooperation, I'm going to be talking about situations where agents, which might be part of an AI system, or they could be human, have some opportunities to cooperate and improve their joint welfare. But for some reason, it's difficult for them to do so. The incentives might not be properly aligned, or there might be sort of a variety of different constraints that make cooperation
my apologies,
difficult.
Kate. My apologies, Kate. Your slides are not on presentation mode.
They are not? Oh, that's too bad. I will try that again. You should be able to see. Are they on presentation mode now?
No, we can actually. I think it may be presenting on an alternative screen.
Okay, it's presented on my own screen. If this is not going to work, I am happy to. It doesn't look as pretty, but I can also do this.
No, if it doesn't work, it's all good.
Yeah. So we'll just continue. I'll just continue by doing this. I apologize. Right. Okay, so where was I? Right, I was defining cooperation. So I'm going to be talking about these cooperative problems, which are going to be scenarios where I said we're going to have some decision makers who would like to cooperate. It's in everyone's best interest, but there'll be barriers for that cooperation. So these sorts of problems are ubiquitous. We see them all the time in our day-to-day lives. So for example, they could be as mundane as trying to agree on when we're going to meet. It could be, or similarly, navigating through traffic as we try to get home. Or they could have sort of global repercussions. So for example, intergovernment negotiations, or similarly kind of trade agreements and commerce among different organizations. Now, what's interesting is if we step back and think a little bit, is that cooperation is something that humans as a species are very, very good at. It's been argued by some researchers that actually, cooperation is our superpower, in that very few species are able to cooperate outside their kin groups, unlike humans. And our societies, for the most part, have evolved to have sort of complex social structure, which sort of enhance cooperation. Now, what we are seeing over the last few years, and certainly into the future, is the advent of more and more AI systems playing an ever greater role in our lives. And so as they become part of our society and become part of our tools that we rely on in our day-to-day interactions, it's going to be very, very important that these AI systems are will not sort of disrupt the cooperative structures that we already have. And furthermore, we'd like to allow them to have the capabilities necessary to both cooperate sort of with others, maybe with other AI systems or with people, and further foster cooperation. But in order to do this, it's going to require sort of levels of social understanding and cooperative intelligence, which for historical reasons have not been included in the way that we think about designing AI systems, even to this day. Can I have the next slide, please? So in a recent paper, some colleagues and I from a variety of different institutions sort of tried to make the argument that now is the time for the field of artificial intelligence to think about cooperation sort of more seriously. And in particular, so we made the argument that any progress towards socially valuable AI is going to be stunted unless we put the problem of cooperation at the center of our research. And in this paper, what we did is that we outlined sort of some of the challenges, as well as what we thought some of the sort of exciting research directions would be as we look further at cooperative AI. And what I'm going to do for the rest of my time here is sort of talk about some of the ideas that we discuss in this paper and highlight some of the preliminary research that we have going on at the University of Waterloo that's making kind of first steps in this direction. Okay, could I have the next slide, please? Now, what I wanted to do is sort of indulge myself a little bit by looking at the history of AI to understand why cooperation has not sort of been centered to the AI research endeavor until fairly recently. And there's a variety of actually really good reasons why this is so. If anyone who has ever taken or taught an Introduction to Artificial Intelligence course, they would have certainly seen some of the diagrams sort of on my slides right now. In particular, what we have is a solitary agent who's interacting with almost certainly a non-social environment, experiencing different rewards or signals from that environment and learning sort of how to interact with it. And this is absolutely a sensible starting point. So don't get me wrong. It's important for our AI systems to be able to understand environments and how to interact with it first before we begin layering on the complications that arise when we are reasoning about sort of multiple agents in a cooperative context. On the next slide, please. Now, you might pause and begin to push back a little bit at sort of my last slide and say, well, hold on. Artificial intelligence has made huge progress through the playing of games, right? So game playing, whether it be early systems like that rise through checkers or backgammon, as well as the most recent work on Go and poker, for example, have led to incredible breakthroughs in AI, sort of broadly as a field. But I think it's important to recognize that most of these games, even though they have multiple agents who are interacting with each other, are not cooperation. Instead, they are conflict. And conflict is a very, very different situation than cooperation. And again, makes a very, very interesting test bed to try out ideas, because these games of conflict tend to be quite easy to benchmark. You understand if you have an AI system which is doing well because it wins more often than it loses. They are mathematically often fairly well understood. We understand how to characterize kind of the equilibrium and the optimal strategies. But they are missing a number of the issues or constraints that make cooperation interesting and also make it non-trivial to take kind of insights that we might get for playing something like Go and translate them into a cooperative setting where we have sort of mixed motives and more challenging incentives. Next slide, please. So what we have been arguing for is a little bit of a change of focus. And so we have this umbrella term that we call cooperative AI. And again, I want to emphasize that this is an umbrella term, and it's going to incorporate and cover lots of different types of research and lots of different research questions. Some of them are already quite active, but I think will be useful to sort of have sort of a common grounding point. And so what we view cooperative AI to be is simply AI research, which is trying to help humans and machines or agents, whatever you want to call them, find ways to improve their joint welfare together. Okay. Next slide, please. Oh, okay. Now, to support cooperative AI, what we have done is that we have argued that to make progress, there's really going to be 4 pillars, which can be studied sort of independently or together. And so there are 4 pillars are the following: that in order to achieve sort of cooperation, our agents or our AI systems will have to be able to have strong understanding. So this means the ability to take into account the consequences of actions, but also to predict the others' behaviors, because in a cooperative setting, there are always going to be others, as well as sort of the implications of another's beliefs and preferences. We will also require communication. So what is communication? Well, it's simply the ability to explicitly and credibly share information with others, and which is going to enhance and improve the understanding. So it's going to be relevant to the understanding, behavior, intentions, and preferences that others might have. We'll also need commitment. So agents or AI systems will have to have the capability of making promises and following through on those promises, because cooperation actually relies heavily on uh, on this ability of promises. And I'll provide an example in a second. And then finally, what we have are institutions. So institutions are some form of social. Actually, can I have the next slide? So institutions are viewed as a social infrastructure. These are shared beliefs or rules that agents have, which allow for cooperation by reinforcing kind of the understanding agents might have about each other, their communication abilities, as well as that support the ability to make these promises. Next slide, please. Now, these ideas, this understanding, communication, commitment, and institutions are all sort of, fairly high level ideas. So what I thought that I would do is that I would try to ground them in a very, very concrete sort of AI example, and that's with autonomous vehicles. If we think about the deployment of autonomous vehicles onto our roads, whether it's with other autonomous vehicles or other drivers, this is inherently going to be a multi-agent problem, and it's going to be a problem of cooperation. You know, every individual and every car or every pedestrian would like to be able to get to where they're going, so ideally as quickly as possible. At this, but that can be challenging, right? Because maybe you want to run through the intersection. That's be a bad idea. In order to work effectively on the roads, these autonomous vehicles are going to need to understand other drivers and road users. Okay, they have to be able to have sort of proper models so that they understand kind of what the intentions of other drivers are. They have to be able to communicate with each other, particularly if they want to navigate through complex sort of situations or intersections. They have to be able to make commitments. So, for example, a driver who's indicating that they want to change lanes is expected to follow through on that promise, on that commitment. And so we're going to need some way for that to be able to be supported. And then finally, if we have a population of drivers, whether they are autonomous vehicles or humans or some combination, it's not obvious to me or to others that the rules of the road that we currently have are actually going to be the most effective. And so there might be some ways that artificial intelligence, a variety of different approaches, might be able to provide better insight as to how we should change some of those underlying rules. Okay, next slide, please. Now, in my last few minutes, what I'm going to do is quickly provide some examples drawn from understanding in institutions, just to sort of highlight a little bit of the research which is going on at University of Waterloo. Next slide, please. The first will be sort of understanding, in particular, sort of work that we have been doing looking at rich game theoretic models coupled with preference elicitation and modeling so as to better support planning for autonomous vehicles. Next slide, please. Now, this is work that has been led by a PhD student, Atricia Sarkar, and she's been asking the problem, how should an autonomous vehicle safely handle other road users where those road users show complex and varied behaviors? And what you can do is that you can realize that that driving is a game, there's interactions going on, and so you can formulate it as what's called a non-zero-sum game, using ideas from game theories between the road users and the autonomous vehicles. The challenge, of course, is that human driving behavior is diverse, and so it can be unclear how you should be modeling those different drivers. So we need some way to model the diversity of human driving behavior, as well as plan an appropriate and safe response from the perspective of the autonomous vehicle. Okay, next slide, please. And so I won't go into detail here just because I don't have time, but please read her work. It's very clever. What she's been doing is proposing sort of we call a generalized dynamic cognitive hierarchy model, which leverages ideas from both game theory as well as behavioral economics that allows for an autonomous vehicle to do robust planning across a population of different drivers on the road who are exhibiting different behaviors. This acknowledges the fact that this is sort of a cooperative problem, but everybody has their own incentive. They're going in different, they're driving to different places, for example, and well as sort of recognizes the fact that people's behaviors can be different. Furthermore, in addition to sort of elegant game theoretic models, she's able to validate her approach across a variety of different driving scenarios in different countries. Next slide, please. I'm now going to move on and give 2 quick examples about institutions before I conclude. And I'll be quite fast because I've run out of time. So institutions are this social infrastructure. They are sort of either shared beliefs or rules that allow us to reinforce kind of these other sort of pillars of cooperation. They can take many forms. They might be informal norms, like holding a door open for someone. There's no rule saying that we have to do that, but this is a behavior that we tend to follow. On the other hand, they could be very formalized. For example, we could have rules that describe how we should make a decision on behalf of a group. For example, the voting processes for elections. Okay, next slide, please. So we have looked at both informal social infrastructure, institutions, as well as more formal ones. We've done a fair bit of work with a PhD student of mine, David Radka, who has been looking at the use of informal teams as a way of promoting cooperation. I don't have time to go into detail here, but what he's been able to show is in sort of complex social dilemmas, teamwork actually provides sort of greater overall social benefit, even more than formulating the problem as a fully cooperative problem where all agents are fully aligned. Instead, sort of these smaller sub-teams seem to lead to better sort of self-organization across the population as a whole, faster learning, and more sort of the mean population reward overall is much higher, rather than having them learn as individuals or learn as an entire collective. On the more formal side, we have been looking at institutions or rules, formal rules, that could be used to support group work. In particular, we're looking at the question about how do you fairly design reward among a bunch of group members who have worked together to accomplish some task. And we have, to that end, what we have been doing is leveraging kind of formal models from the social choice literature, which provides axiomatic approaches, coupling that with data-driven approaches so that we can kind of get the best of both worlds. So we can get sort of the formal properties from axiomatic methods, but at the same time recognizing where for the particular population that we're working with, we need a little bit more flexibility. Okay. Next slide. Finally, I'm just about to conclude. So I've sort of been talking about sort of cooperative AI, which is this framework where we think about AI research trying to help humans and machines find ways to cooperate or to improve their joint welfare in different ways. Next slide. Okay, this is an interdisciplinary endeavor. It was going to rely on building off, work inside the AI community, whether it's machine learning, NLP, AI alignment, multi-agent systems, but as well as reaching out to other fields such as biology, sociology, economics, and law, who also think very hard about cooperation in different ways and getting together and having hopefully productive conversations about what it means to cooperate and what are the problems of cooperation. Okay, next slide, please. Now, finally, I guess my main point is that cooperation I believe, should be at the center of AI research, and that it's unlikely to emerge as a byproduct of other kinds of AI research because cooperation raises other questions which have not necessarily been addressed by sort of the single, looking at these problems as a single AI system. The research in the area is inherently interdisciplinary and it's going to require many different perspectives, which raises, of course, sort of other challenges, as interdisciplinary work is always difficult and always sort of a problem of cooperation itself. In particular, what we're going to need are new benchmarks, new challenge problems, and also ways of thinking about how we should move away from individual objectives to sort of shared, poorly defined ways that humans solve social problems, either by creating language, emergence of new norms, as well as different institutional structures for which AI might provide insight, or which we might be able to look at current institutions and bring them into the world of AI. Okay, and I'd like to thank you very much.
Sorry, I was on mute. Thank you very much, Kate, for the excellent presentation. This is an exciting area where you see traffic congestions on the 401 on the slides, and so it's a big endeavor. Um, one of the things I wanted to ask you was this. You had it twice, I think, on your slides. This idea of cooperative AI being built for the goal of maximizing social welfare.
Yeah.
And so do you see this, and I know you talked about this transdisciplinary approach at the end, but how much do you think it is possible to use AI to create social justice and create this social welfare, maximize and so on? How much does AI play a role? How much social sciences plays a role?
Right.
Where do you see?
Yeah, absolutely. So I think this is actually a really good question, because I want to emphasize that this has to be an interdisciplinary endeavor. And I think it will be fruitful going in both directions. So as we design more and more complex AI systems that we are adopting into our society, or even in our into our day-to-day uses, I think there are interesting insights that come from all these other fields that would allow us to improve our designs, would inform us as to how we should be doing our evaluations. Like, are our loss functions the right things we should be we should be minimizing, for example? So I think there are definitely interesting insights and questions that could be brought from other fields inside AI, and we just have to sit down and listen.
Yeah.
On the other hand, I think AI gives us a lot of interesting new tools and new questions and new ways of doing things, which could also be useful in other contexts, right? So I think I can absolutely have seen examples where there are some economic problems which have changed because the computation and the computational power, but also sort of the algorithms and the machine learning techniques are now allowing them to design sort of complex markets that were not possible in the past. So it's opening up the possibility of sort of new institutions. I think an interesting example of a research project I was in no way involved in, but I thought was really cool, was something that was published, actually, well, in an archive last year, but it was published very recently from Salesforce. And this was this AI economist, where they were using machine learning and reinforcement learning in order to test out policy ideas in an economy. So they were interested in tax policy. And so, the advances that have been made in reinforcement learning kind of allow us now, for example, to have rich simulation platforms where some of these social sciences fields can now begin to experiment with and try out new ideas. So I see it very much in both directions.
Yeah, it's amazing, and I have so many questions myself, but I've been tasked with reading audience questions for you, so I'll do that. First question: can you describe the opposite of cooperative AI to give us a better sense for what it means in practice?
Okay, sure. So what is not cooperative AI? It's a good question. So game playing. I don't think chess is an example of cooperative AI, right? But I think actually a lot of the supervised learning applications or reinforcement learning applications are not cooperative AI, right? So, prediction, classification of images. There's no social context. It's not interacting with people, right? It's very cool. There's been huge advances in that space, but it is not cooperative because it has no notion of sort of the social context.
Yep. Excellent answer. So next question, great talk. What are your thoughts on social robots with respect to cooperative AI? Is that another use case that would be relevant?
Yeah, absolutely. So I think there's a lot of really, really interesting and challenging questions inside the subfield of social robots. I'm certainly not an expert in that area myself, but the little bit that I know, they have some really, really interesting, challenging questions. And I think it will be really important to make sure that the social robotics, because they think very much about social interactions, will have sort of interesting questions and insights that could be brought across to other subfields of AI. So I think that's definitely a use case that's highly, highly relevant. And I think that the rest of the AI community have a lot to learn from.
Next one, how can AI distinguish other agents from objects in the environment which are endless? A goose, a child, or a drunk pedestrian, or a part of the context?
Hi, Yulita. I'm going to punt on this question because I don't know. I'm hoping other people will be able to do this. So I am right. So with the autonomous vehicle, I was using autonomous vehicles, autonomous driving as an example, and you're right. So one huge challenge there is going to be recognizing the environment. And I know that there are people who are working really, really hard on getting that done. I think that is some of that is going to be separate from the research agenda that I'm interested in, right? It's important work that has to be done, but it's very much not cooperative AI. Instead, it goes back to sort of, some of the advances in supervised learning that we're seeing to sort of recognize the environment. Where the cooperation would come in is if we, if we have to negotiate. How do it? Which I know that's something that you've been interested in before. So how do we negotiate? So if we already know that we're working with maybe with a person or somebody from a particular population, how do we best struggle? How do we do preference modeling? What sort of techniques should we be doing in order, taking into account that what we actually want to achieve is some some joint beneficial outcome? And what advances are needed there?
Mm-hmm. And you have some agents who are non-cooperative agents within the cooperative environment.
Absolutely. And incentives can be complicated. So again, a lot of these cooperative problems, we agree, there's some outcome out there, it'd be great for all of us. But the incentives are such that, we just can't cooperate. I mean, the prisoner's dilemma is sort of the classic example there. And so can we use AI, or are there insights that can be used to kind of avoid those situations?
Mm-hmm. Mm-hmm. Commitment to the cooperative AI, this is in a question form. Commitment to the cooperative AI is similar to accountability. What is the relationship between responsible AI and cooperative AI?
I think they're very, very closely aligned, right? I think, and in fact, I did have a slide up there actually, I ended up skipping it because we had a little bit of a technical problem where I did talk, which I had very quickly, that maybe like safety and alignment is somehow related in this space. So I think that responsible AI and cooperative AI are not the same thing, but I think they complement each other. And so there will be overlap.
Mm-hmm. So a big part of responsibility is getting the perspective of many different people into the picture, and cooperative AI speaks directly to that. So this has been excellent. Thank you very much, Kate. We have Ricardo on as well, who has a question for you.
Yes, hi, Kate. A great talk. And I have a question on two angles that immediately I got in my mind when I saw your presentation. One is that you want the joint welfare, and for me there's a big asymmetry. I don't care much about the welfare of the machines. I really care about the welfare of the humans. And with that, I also think that for me it's not only the cooperative part that is important, and for me the complementary part. So I want AI to help us in the things that were not good, and don't try to replace us in the things we are good. So how do you think these two aspects go into cooperative AI?
Yeah, actually. So one aspect of so I think you have a good point. So I was taking kind of as broad a stance as possible that agent AI systems also have value, and maybe they will have preferences that we need to respect. But I think more realistically, what we will have is our AI systems who are representing others. So we can imagine negotiation, right? So I am not negotiating directly with you, but we have our agents are negotiating. And so we're talking about joint social welfare. So we want to maximize our social welfare. Are we maximizing the social welfare of our negotiation agents, or are we maximizing our own welfare, right? So it's a little bit of semantics. I think my own personal interest in this space has to do with the institutional design. So when we talk about welfare, we are actually talking about sort of individual people's welfare and trying to come up with good collective decisions. And AI tools and techniques could be used to sort of structure the incentives, improve the communication channels, kind of drive us towards sort of a good outcome, despite kind of our own self-interest. So in that context, I think social welfare completely aligns with individual human social welfare.
I think we have a last question that maybe we can take, and also for me would be interesting to know where we should focus our research in these 4 pillars of cooperative AI. So because they are not in the same level today.
No.
Ibrahim, you want to read the last question, or? Oh, okay. Yes, it's there.
Sure. Yeah, I'm here. Competitive cooperative agents can lead to very interesting and innovative solutions. To what extent should we limit or delimit competitiveness in order to regulate emergent behaviors that might be harmful?
I think that's a really hard question. I honestly don't know. So this is a situation where it would depend very much on the underlying application domain. And I would want to defer strongly to experts in other fields. Right? I would want, the lawyers to tell me what the right thing, or the philosophers, or the applied ethicists to tell me. This is not a decision that I, as an AI researcher who loves the math, should be in charge of. Right? So this is a call out very much for interdisciplinary approaches.
Yeah.
Thank you, Kate. Thank you, Kate, because that's a human answer that you don't hear too much from machines. I don't know. That's an answer we need to hear more. And thank you, Ibrahim, to be here, and I will take over the MC role. And thank you, Kate, for the very interesting presentation.
Okay, thank you.